Hello class, today we're going to do lesson 6.8, which is on the multiplication principle. So our very first vocab word for today is tree diagram, and it kind of, just the word tree diagram, we're going to draw a picture basically that's going to somewhat resemble a tree with like branches and leaves to help us figure out probability. So a tree diagram, it's a way to count the number of possibilities. It uses branches to list choices. So for example, if I wanted to think about what I could wear today, and I had a black shirt, a brown shirt, and a white shirt. So I have 3 shirts, and I have 2 different pairs of pants, okay? I either have black pants or jeans. So I could wear a black shirt with black pants, or I could wear my black shirt with jeans. Well, I could wear my brown shirt with black pants or my brown shirt with jeans. And same thing, white shirt with black pants and white shirt with jeans. So how many different possibilities are there? Well, there's 1, 2, 3, 4, 5, 6 possibilities for having 3 shirts and 2 pants. So it's kind of a visual way to figure out how many possibilities there are. So example 1, at a picnic lunch, you choose 1 sandwich and 1 salad. The choices include a veggie burger, hamburger, tuna sandwich, garden salad, and a fruit salad. Okay, so that's all the different possibilities. How many different picnic lunches are possible? All right, so let's see here. Let's go ahead and pick, I'm going to do a V for veggie burger, an H for hamburger, and a T for a tuna sandwich, okay? So I've got a veggie burger, a hamburger, and a tuna sandwich. Okay, now I either have a garden salad, so I'm going to do a G for garden salad, and an F for fruit salad. So, because I choose 1 sandwich and 1 salad. So here are the different possibilities here. We could have a garden salad or a fruit salad. If I chose the hamburger, we could have a garden salad or a fruit salad. And if I choose the tuna sandwich, we could have a garden salad or a fruit salad. So how many total possibilities are there? There's 1, 2, 3, 4, 5, 6 different picnic lunches. So I'm going to write that down. 6 different picnic lunches are possible. Okay, so that's a way to figure that out using a tree diagram. Let's do another one. Example 2. Suppose for each picnic lunch in example 1, you also get to choose 1 fruit. So this is in addition, okay? The choices include the following: apple, banana, orange, and grapefruit. Copy the tree diagram in example 1 and add the new choices. How many possible picnic lunches are there? So the first part is the same. I'm going to just go ahead and I'm going to erase this here and give myself more space. I'm okay if you do that as well, to just add on to your diagram rather than creating something new. Okay, so our choices, we've got an apple, a banana, an orange, and a grapefruit. I'll do GF here for grapefruit. Okay, so you're going to tack these onto each already possibility. So we've got, you could have a veggie burger with a garden salad and an apple, a veggie burger with a garden salad and a banana, veggie burger, garden salad, and orange, or veggie burger, garden salad, and grapefruit. Oh gosh, I'm going to run out of room here. All right, so there's 4 more possibilities added on to each one of these already made options, okay? All right, so I'm going to add these over here for this one. We've got the 4 possibilities, and I'm going to do this extra long here to give myself some space. So we've got the apple, the banana, the orange, or the grapefruit. Okay, on this one, we've got the apple, banana, orange, or grapefruit. apple, banana, orange, or grapefruit. And apple, banana, orange, grapefruit. And your tree diagram doesn't have to look, picture perfect. It's okay if it's not that nice looking. That's okay. So now let's go back through. Let's go back through and let's count. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 different possibilities. Okay, 20 possibilities. Oh, okay, that's what I thought. I thought I had missed one here. Excuse me. So sometimes everybody makes mistakes, right? I had missed one of the ones back here, all the way over here. I had missed putting the possibilities for that veggie burger with a fruit salad and those choices. So I actually have 4 more choices, and yeah, my diagram is not very nice here. It's way too cramped. So we have an apple, banana, orange, and grapefruit for over here too. So I am sorry about that. Okay. So originally I should have made myself more space. So if I add on those 4 possibilities to my already 20, I have 24 different picnic lunches are possible. Maybe in watching that video, in this video, you had already caught that, but yep, 24. And if I was going to do something with this many different possibilities, I would probably want to make sure it's very spread out on a piece of paper so that I don't accidentally miss one, because that is a good possibility. Now, you might be asking, well, gosh, like as we get more and more choices, like let's say there was a dessert option. Now we're going to have so many different choices, and I don't want to have to make this ginormous tree diagram. Well, what you can do is something called the multiplication principle. It uses multiplication to find the number of ways 2 or more events can occur. All right, so I'm going to read this box here. It says, if one event can occur in m ways, and for each of these ways, a second event can occur in n ways, then the number of ways that the 2 events can occur is m times n. The multiplication principle can be extended to 3 or more events. Okay. So, and another vocab word is the set of all possible outcomes of an experiment is sometimes called the sample space. So, really it's just like how many outcomes the number of outcomes, the number of possible outcomes is called sample space. Okay, so let's actually try multiplication principle for example 3. It says you roll a number cube and you randomly draw a marble, and this is randomly draw a marble, from a bag. There is 1 marble for each of the following colors. We have red, blue, green, and yellow. Okay? Use the multiplication principle to find the number of different outcomes. So, the very first one is the cube, the number cube. We're going to take the possible numbers in the number cube, and we're going to times it by how many marble colors there are, okay? So on a number cube, there are numbers 1 through 6. So that means that there are 6 different numbers. We're going to take 6 times how many different colors of marbles are there. There's red, blue, green, and yellow. That's 4 different colors. 6 times 4 is 24 different possibilities. Okay, so that was much quicker than having to draw one of these tree diagrams, okay? But I have to say, I like the tree diagram because it really does give you that visual, but this way is way quicker. Example 4, you roll a number cube, randomly draw a marble from a bag, and flip a coin. So even before we go on, I'm going to write down there are 6 possibilities for the number cube, okay? There is one marble for each of the following colors, red, blue, and yellow. So there are 3 marble colors in the bag. Use the multiplication principle to find the number of different outcomes that are possible. If I were to flip a coin, there's heads and tails, so that means there are 2 possibilities for the coin. So if I was going to use the multiplication principle, I would do 6 times 3 times 2. 6 times 3 is 18. 18 times 2 is 36. So there are 36 different possibilities. Whoops, missed an I here. Okay. Moving on to example 5. The access code for a car's security system consists of 4 digits. You randomly enter the 4 digits. What is the probability that you choose the correct code? Alright, so here's the deal. It's going to be 4 digits long, so I'm going to do those 4 spaces, and we know that we're using multiplication principle. So we're going to multiply those numbers, okay? Now, 4 digits, if you think about this, you've got numbers 0, 1, 2, 3, 4, 5, all the way up to 9, okay? That means if I were to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 numbers to choose from between 0 and 9, okay? So the digits between 0 and 9, there are 10 choices for the first number. There's going to be 10 choices for the second number, 10 for the third, and 10 for the fourth. Because it doesn't say anything about, like, let's say the code was 4642. It doesn't say anything that, like, these numbers can't repeat. So that means there are 10 choices for the first number, 10 for the second, 10 for the third, and 10 for the fourth. If I were to multiply that through, that's the number 10,000. Now, it does say what is the probability that you choose the correct code. Well, probability means number of correct options over the number of total. We know that there are 10,000 choices, but only one of them is correct. So this would be the probability. Okay, so it's kind of combining what we learned in 6.7 a little bit. Example 6. Your computer password has 2 lowercase letters followed by 6 digits. Your friend randomly chooses 2 lowercase letters and 6 digits. Use a calculator to find the probability that your friend chooses your password. So we have to think about this. Your computer password, it has 2 lowercase letters. So in the alphabet, there are 26 letters from A to Z. So there are 26 letters. It doesn't say anything that like if I use the letter A for the first one, I can't use it for the second one. It doesn't say that. So there are 26 for the first one, 26 for the second one. Then it says it uses 6 digits after that. So we have 1, 2, 3, 4, 5, 6. Okay, and just like our last problem, the number of digits between 0 and 9, there's 10. And again, it doesn't say anything about those numbers not being able to repeat themselves. So if I were to use a calculator to find out this number, it would be 676 million. Okay, and what's the probability of your friend getting the right password? Well, only one password is correct, and there are 676 million possibilities. So this would be the probability. All right, thank you again so much for watching.